Good day. So this will be a General Mathematics Week 8 Learning Competency. First one, determines the truth values of the proposition, illustrates the different forms of conditional propositions. So before that, let us have a short review on a proposition. Proposition is a declarative sentence that is either true or false, but not both. If a proposition is true, then its truth value is true, denoted by capital T. Otherwise, its truth value is false, is denoted by capital F. So propositions are usually denoted by small letters. We usually use the P, Q, R, and S to denote the given statement is a proposition. Moving on, example, determine whether the statement is a proposition or not. Ordaneta City is one of the four cities in Pangasinan. Solution, this is this declarative sentence since Ordaneta City is one of the four cities in Pangasinan. The statement is true, therefore P is a valid example of a proposition. Now, let us have this example. Let P and Q be proposition. Construct table for the compound proposition. So we have P implies Q and Q implies P. So P will be your hypothesis and Q now will be your conclusion. Well, the other way around, Q now will become your hypothesis and P will be your conclusions. Note that there are two propositions, the P and Q, involved in compound proposition. Thus, truth table will contain 4 rows. Now, the question is, how we're going to determine now the number of rows in the truth table. Let P and Q be proposition. Construct table for the compound propositions. So there are two propositions, the P and Q. Therefore, your n now is equal to 2. Then use 2 raised to n, wherein 2 is the base or the constant and n will be the number of propositions. So if we have two propositions, we are expecting to have 4 rows. And since we have 4 rows, then divide now for constructing the column of P, the number of column into true, true, false, false. So we divide into 2 equal parts. 2 true, 2 false. Then Q now will become alternate. True, false, true, false. Since P now will be your hypothesis, so P implies Q, both of them are true, so true, true. True, false will become false because the conclusion is false. False, true, since the conclusion part is true, therefore the statement will become true. If both of them are false, then the statement will become false using the biconditional statement or conditional statement. Now, if you're going to reverse, Q now will become your hypothesis and P will become your conclusion. So true, true will become true, false, then conclusion now will become true, therefore the statement will become true. Next, starting from here, your hypothesis is true, then your conclusion is false, therefore the statement will become false. Both of them are false from here, false, false will become true. Then using the condition compound proposition, and we're going to use the conjunction. The essence of conjunction, once we have false, then the statement will become false. Otherwise, if both of them are true, then the statement will become true. So we have here true, true will become true. False, we have the presence of false going to true, then the statement will become false. True, then we have false, therefore this will become false. And both of this one, of both of this, true, true, therefore the statement will become true. And this will be the final product of our compound proposition. So this will be your compound proposition. Now, moving on, So compound proposition will be this one. Moving on, consider the compound proposition P implies R and Q implies R. Then we have to close this one. Then P or Q implies R. So there are three primitive propositions. Take note, we have P, we have Q, and we have R. Then your N now will become 3. Using 2 raised to 3, then we are expecting that our table now will give us 8 rows. So, since we have 8 rows for the value of P, then 8 divided by 2, then we have 4. Then we're going to start now. There are 4 true and 4 false. Out of this 4, we divide this 4 into 2. Therefore, we have 2 true, 2 false, 2 true, 2 false. Then alternate now for the value of R. That is true, false, true, false, true, false, true, false. Now we have here the operation P, then R. Your P now, your P will become your hypothesis. So your P will become your hypothesis. Then your R will become your conclusion. So true, true, therefore we have true. Then so on, true, true, both of them are true. So P, then we have true going to R, false, therefore we have false. Next, true going to true, and the operation is this one, so we have true. Then we have true, false, therefore we have false. False, true, so the conclusion part are true, therefore we expect that we have true. Then we have false, false, then it will give you true, true. Going to this one, your reference now will be your Q. So this will be your Q. Okay. Going to your R. So this will be your conclusion, and this will become your hypothesis. So out of this, true, then true will become true. True, false will become false. This one. False, true will become true because the conclusion is true. False, false will become true. Then true, true will become true. Then we have true, false. So the conclusion is false, therefore this will become false. Then false, true, so the conclusion is true, therefore this will become true. Another way is both of them are false, therefore we expect that this will be false because the operation is this one, conditional. Okay, next, if we're going to have this operation, this one, compound, we're going to have the basis for the operation should be this one. And we have the operation which is conjunction. In conjunction, as long as we have false, then the statement will become false. Otherwise, if both of them are true, then the statement will become true. So both of them are true. So you expect that this will be true. So false, false, true. So we have both of them are true. We have the presence of false. Therefore, this will become false. Both of them are true, true. So true, false. We have false here. Therefore, we have final answer will be false. Both of them are true. So true, true. So this will be the operation involved in this part. Now, the P or Q now, we have P or Q. The P or Q, as long as we have true, then the statement will become true. So true, 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 true. We have If both of them are false, then that will be the time this will become false. So we have only two columns for false. We are dealing with the P and Q. Now, if we're going to have this as hypothesis, going to R, this one, okay, so true going to true will become true. True going to false, this will become false. True going to true will become true. Then we have true going to false. So we have false. Then we have true going to true. Therefore, we have true. False going to false. We have true. Then false going to true is true. Then false going to false is true. And if we're going to have this as a complete operation, that's why we have the presence of S to denote that we have a compound operations. If we're going to do this operation, we will end up with, this will be your hypothesis column, and this will be your conclusion column. Therefore, all of them will become true. And out of this concept, note that regardless of the truth values of the PQ and R proposition, S is always true. Such propositions are called tautologies. So once we ended up with the true values all over, then meaning that is a tautology. A proposition that is always true called tautology, while a proposition that is always false is called contradiction. Then we denote the tautology by the symbol tau, and contradiction is like a null set symbol. Now, given this operation, if we're going to have a compound operation of the given propositions, given the concepts of this operation, we ended up with a false in all column in any combination. So all of them are false. Note that the given compound operation is false in any combination of the truth values of P and Q. Therefore, this is a contradiction. Okay. Moreover, if we have this operation and we ended up with true values in all combinations, then this is a valid example of tautology. Regardless of the truth values of P and Q, always true, so it is a tautology. Thank you for watching. Have a nice day. Keep safe.